Alright, so in this particular video series, we are going to talk about Langchain all the way from getting started basics to complex applications that we can build using Langchain. So what exactly is Langchain? Langchain is a framework for developing applications powered by language models. It enables us to build applications that are data aware, which basically means using a language model and different sources of data and then sort of combining them to produce a more meaningful application. And also, um, it has two main aspects. So first off is the usage of components, which are nothing but abstractions of large language models, which sort of gives LangChain a more modular approach to build applications. And second, the off-the-shelf chains. So chains are a way to link different components and different chains together in order to build high-level specific applications. So in this particular notebook right here, we are going to see the very basics of LangChain. So the first step is to install LangChain and OpenAI libraries. Now once that's done, we need to import the important classes, that is OpenAI. And so in order to utilize and leverage OpenAI API keys, we need to first create an account in OpenAI and register our keys, and then we can use it. Now I have my key stored in creds.json through which I'm accessing it. The next step is to instantiate the OpenAI class. So it basically requires two parameters. First is the OpenAI API key and second is temperature. So in this particular application, that is, we are basically asking the large language model for a good name for a basketball team. We really require the model to be creative and want some sort of randomness. Hence, the temperature is set to higher value. Now this is a chat model which is a bit different from the normal LLM prediction because that's sort of a completion model and this is a chat model. So although right here is a very basic example of inference of a chat model, but basically for chat models, the input that is being passed to the model is some sort of a context, that is some sort of a message history along with the current input from the user, whereas in completion models, the input is very straightforward. That is some sort of a question that needs to be answered. So we import the chat OpenAI class from langchain.chat models and also import other important classes from langchain.schema that are AI message, human message, and system message. And in this particular case, as the example is very straightforward, we are not really utilizing the power of chat models, but we'll look into more complex examples as we go on. So the human message over here is translate this sentence from English to Hindi. That is, I love programming, and the model responds with the corresponding output. Next up, we have prompt templates. So for prompt templates, usually what happens is the user input is not directly passed to the model directly. Rather, we add the user input to some sort of a larger piece of text, which is then fed to the model for prediction. So in this case, the template is what can be a good name for some input. And so input right here is a variable that needs to be filled by the user. And then we fill that particular variable by passing in value called basketball team. And so the prompt template then becomes, rather by filling the prompt template, the prompt then becomes what can be a good name for a basketball team. Now that we have the models, that is the large language models and the prompts, chains are a way to link these two different objects there are models and prompts. Um, so it's as simple as calling the LLM chain, instantiating the LLM chain class, and then calling the run function on that particular object. It basically requires two parameters, LLM and prompts, and then we get the desired result. Now it's a bit different for chat models. So for chat models, we have the system message prompt template and the human message prompt template. And then once we have both of them, we then create the chat prompt template, which is a combination of the system message prompt and the human message prompt, which is then basically passed to the user. And finally, we get the desired result. So one important thing to note here is that all of the input variables need to be passed while running the run function over the chain object. That is, the input language and the target language are the input variables for the system message prompt, whereas text is an input variable for the human message prompt. So they all need to be passed at runtime. So far, we've looked at chains which basically compute a predefined sequence of steps, but that is not what happens in the real world. In real world, we want a program which computes different, assesses different situations, and then decides what steps need to be run and in what order. And chain and agents do exactly that. They basically use prompts, large language models, different tools, and chains in order to really understand what is going on in the environment and then decide what steps need to be run and in what order. So in this particular example, we are basically going to use two tools. One is the SERP API, which basically is an API that queries real-time Google search engine to get results. And LLM Math is a calculation tool. We initialize the agent with the tools, the large language model, and the type of agent, that is zero short React description. And finally ask the model that what was the highest temperature in LA yesterday in Celsius, and what is the number raised to 0.023 power. So it computes this particular complex question by breaking down into different thoughts and actions, and then finally observes the output. So first it performs the search operation of what was the higher temperature in LA yesterday. Now once it has the answer, it basically thinks that it needs to convert it to Celsius and then raise it to power, and then uses the calculator to get the final result. Next up, we have memory, which is a very important component when it comes to Langchain. So far we've looked at components and applications that are stateless, that is, that they do not store anything in memory. But in real world, we require applications to reference past interactions, and hence we require memory to understand memory to understand what is going on in the environment and to then produce meaningful output. For normal completion LLMs, it's as simple as calling the conversation chain class by passing in the large language model and then um, calling the run function on the object. And so if in each iteration, the human and the AI messages get stored in a large piece of text, which is considered as context in order to produce the next output for a given input. So for example, for the human message, hi there, the AI produces, hi there, it's nice to meet you, what brings you here today? And the conversation goes on and on. And as you can see, the history keeps on accumulating all of the previous messages. Whereas with chat models, it's a bit different because instead of condensing all of the messages in a large piece of text, it basically keeps each message as a separate or a unique memory object. So for this particular prompt, system message prompt and for human message prompt, we have two different messages, which are two different unique objects in the memory. And so there is no single piece of text which basically has all of the information. And it's as simple as calling in the predict function on the conversation object. And so conversation buffer memory is the most simplest and the most common type of memory in Langchain that basically keeps all of the previous messages in memory. For the input hi there, we get hello, how can I assist you today? And we get the desired result for each input where the model takes into account the previous context as well. Thank you for watching the video. See you in the next one.